test 2. All right. So section 8.1, and it's graphing and writing specifically linear functions. So we talked about functions before, and what we had with a function, I'm just going to write a little note at the top here. I could have given you a function like f of x equals, we could say x squared minus 2, something like that. And when I gave you a function, I could have said, or probably did say, find f of 5. Now, when you had a function f of 5, f is the name of the function, and 5 is the value of x. That's what we worked with. So what we do is in the function that is defined, f of x is equal to x squared minus 2, wherever there is an x, we put a 5. And so I would have written this as 5 squared minus 2. And then if you simplify this, that means f of 5 would be 25 minus 2 is 23. So that is something that we talked about, I believe, in chapter 3. And we're going to now look specifically at linear functions, okay? And linear, remember, those are our equations. Linear equations were equations that described lines specifically. We looked at the slope. There were 3 different types of linear equations. We had the standard form, we had the slope-intercept form, and we had the point-slope form. So now we're going to look at a linear function. And just as a reminder, a function is defined as an equation where every x value has only one y value. And we often replace the y with the notation f of x, okay? We can replace them. So another way to look at it is whenever we say f of x, we really mean y. We really mean y. But we have this function notation that we use. So f is the name of the function. X is the variable that is to be replaced with a value. And we often call x the independent variable, or we can call it an argument. Okay. So with the example I want to take a look at, I want us to graph the linear function. I want to do this using our function to find different values. All right, so if I looked at this function f of x, I'll make my little chart. And here's my x. Here's my f of x equal to 3/4 x plus 3. And then I'm going to put it together, and we will have my f of x value. Okay. Now remember, we can replace, it looks weird to have it that way, but remember that we can replace f of x with y. Okay. So these 2 different ordered pairs, x, y, and x, f of x, they mean the exact same thing. They just look different. So when I look at the function f of x is equal to 3/4 x plus 3, I'm going to use, we call them smart value for x, because I have a fraction. And I don't want fractions when I graph. You can, but I don't want that. And I see that if x was a multiple of 4, well, then the denominator would be gone. And this is what so here's our x. I'm going to let x be a 4 because I can choose my values. And f of 4 is equal to, all right, 3/4 times 4 plus 3. Now notice that the 4's cancel. 3 plus 3 is 6. So my ordered pair is 4, 6. So that is one of the points on my line. Let's take a look at another one. If you can, use 0. If 0 is available, use 0. And actually, with every linear equation, you can use 0. So with that, well, 0 times 3/4 will give me 0. So really, this is going to be equal to 3. 0, 3. And then let's take a look at one more. Another nice multiple of 4 would be -4. And again, I'm choosing values to get rid of the fraction, right? To get rid of that denominator. So I put in that -4, and I have 3/4 times a -4 plus 3. All right, well, 3/4 times a -4, the 4's cancel, but I get a 1 here. So -3 plus 3 is, fit this in, it's a 0. So -4, 0. That worked out really nice. So what I'm going to do with this information is, it says to graph. I have 3 points, and so I'm going to graph. So 1, 2, 3, 4, 5, 6. Make it nice and neat. And let's plot. So 4, 6, so that's to the right 4, up 6. We have the point 0, 3, 0, 3. And we have the point -4, 0. I'm going to grab my ruler, put it on. There we go. Draw my line and the ends of the arrows. Okay, and this would be your answer right here. So I found some points, and I was able to plot this. And if you look at it, if you look at this equation, another way that we could have done this equation would have been to notice that it is in slope-intercept form. And so you can pick out the y-intercept, which was a 3, and we ended up finding it, got 0, 3. And if you count out the slope of what we have, it is 3/4, the value that is on x. Any questions? All right, so we can always use plotting points to find these lines. Let's take a look at the next example. Find an equation of the line with slope -1/3 and y-intercept 0, 4. Write the equation using function notation. All right, so we have our slope. It's -1/3. So I know that m is equal to -1/3. And we have our y-intercept, 0, 4. I know that my b is equal to a 4. So when I write my equation, y then is equal to, it's mx plus b, so -1/3 x plus b. That equation comes from chapter 3. But this tells us specifically to write it in function notation. To write it in function notation, all we have to do is replace the y with f of x. So we will write f of x is equal to 1/3 x plus 4, and that will be our answer. Any questions? All right, well, let's take a look at one more. I think we have a couple more examples. This might be our, excuse me, look ahead. This is the last example for this section. Again, it's combining information that we've already looked at, right? We're just combining linear equations with function notation. So the next example is find an equation of the line whose slope is 5 and it contains the point of 4, -3. So there are a couple of ways that we can do this. One thing I noticed is my slope is 5, so I'm going to write that out, pick out that information. And here's my 4, -3, and it's not the y-intercept, right? This would be like our x1, y1 when we use the point slope form. Now, point slope form looks like this. It's y minus y1 is equal to m times x minus x1. Okay? Now I'm just going to put the information in and then solve for y, and I will have a linear equation. So y minus y1, and y1 will be this, y1 is this -3 is equal to m, which is a 5, times x minus x1, and my x is the 4. Okay, I have a nice equation, and I will solve for y, because if I want to put this in function notation, I have to have that y alone. All right, well, minus a 3 is a plus. Let's go ahead and clear parentheses by multiplying this 5 through. Okay. To get y alone, I subtract 3 from both sides. And there's the equation for my line. Now what it says though, write the equation using function notation. So for function notation, what I will do is I'm going to replace y with f of x. So instead of the y, I'm going to write f of x is equal to 5x minus 23. And that is our final answer. So this is the biggest thing I want you to get from 8.1 is that we can write a linear equation as a linear function. And that when we see f of x equal to something like 5x minus 23, that we know that we can graph it, that it is a line.